Welcome friends, welcome to JC Connect. Today we are going to study about the geodetic surveying, that is part 2. Now here we are going to study about the strength of the figure that we have seen, the different figures or different triangulation system. We call them as our different triangulation figures. So we are going to study about the strength of those figures. Now those things are going to be related with the well conditioned triangle and the criteria of the strength of figure, right? So these two things we are going to study here. Now here if you see the strength of triangle, that is the triangulation system is formed by the measurement of angle. The path that gives the minimum error must be chosen, and the strength of figure of a triangulation system may be defined as the number of that gives the least error in the computed length of the last line due to the shape and composition of the figure. Now here this is the thing is that you should understand what is well conditioned triangle and what is ill conditioned triangle. Now there are various triangle figures, and accuracy attained in each figure depends on the magnitude of the triangle in each individual triangles and the arrangement of the triangle. Now if you take about the shape of the triangle, and that should be such that any error in the measurement of angle shall have a minimum effect upon the length of calculated side. Such triangle we called as what? A well conditioned triangle. Now in the triangle, one side is known from the computation, the computation of adjacent triangles. The error in the other sides will affect the rest of triangle figure. In order to that these two sides equally accurate, they should be equal in length. This can be attained by the making the triangle isosceles. That what the basic thing that we are going to consider. Now the strength of triangle or the criteria of strength of figure. Now here the strength of figure is a factor to be considered in establishing the triangulation system, for which the the computation can be maintained within a desired degree of precision. The US Coast and the Geodetic Surveying has developed a very rapid and convenient method of evaluating the strength of triangulation figure. Now the method is based on the expression for the square, the square of probable errors. That here I have shown it as L square. This we are going to call it as what? Square of probable error, and that would occur in the sixth place of the logarithmic of any of any side. If the computation were carried out from the known side, though through the single chain of the triangles after the net had been adjusted, or means net means the no the triangle system of triangle had been adjusted for the side and the angle conditions. Now the expression L square, here see that what I'll show you here. L square is here, L square is equal to, I have got this expression, that is 4 by 3 d square d minus d sum of row a square plus row a b plus rho b square. Now this is the value, see here, that is sum of rho a rho b, no that rho a rho b plus rho b square, that is the summation of values of particular chain of a triangle through which the values of sum of no the values through which the values computation is carried out from the known line, right? So that we called as what? This is what that sum is shown here. Now here if you see that 4d square by 3r, if we take this whole thing as a r, then this is the thing here what I have shown here. I am going to consider this whole thing. See here, this whole thing we are going to consider it as r. Now that I have shown here, this whole thing is r. Now this value you can get from a table. I'll show you where is that table. Here it is there in my slide. Somewhere I'll show you. Yeah, this is the table. Here you can say that this is the table which gives you the value of sum of rho a square plus rho a rho b plus rho b square. Now that value you can get here for say here, if you see this, for 10 degree you will be having you'll be having an angle here. So this for 10 degree for both the sides LA and LB. Here this is the value of rho a square plus rho a rho b plus rho b square. This is the value for this, right? Similarly you can have the value for 10 degree and for 12 degree. Here this is the value. Like that you can get the values, and if it is anything which is there between the these prescribed values here, this side and this side, you can interpolate and you can get the that remaining value. This is the very important table that we have to keep in mind while solving the problem also. That thing is going to be there, right? Now we are discussing about this, right? So here this is what the whole term I have elaborated. This is very important thing, that right, L square formula. And here you can see the what is L square. L square is the square root of or the most or maximum no, probable error. R is the strength of figure. D is the right. Uh, D is the no probable error, and capital D is the number of directions observed, excluding those for the baseline. Except baseline, whatever the directions are there, those we call as capital D. Whereas capital C is the number of geometric conditions. Now here you will be having the condition C is equal to n dash small s dash plus 1, that is plus n minus 2s plus 3. Now the small n is total number of lines, n dash is the number of lines observed, s is the total number of stations, s dash is total number of stations occupied actually. Now this n dash minus s dash plus 1 is the number of angle condition, and n minus 2s plus 3 is the number of side condition. So these we are going to see this, how to get this. Now if you take a figure and if you count the number of lines, then that is your small n. Here this is your small n, right? I'll show you here. This is your small n. I'm not getting the cursor exactly on that line, but there is a problem here with my slider. Okay, this is the small n, which is that is total number of lines. Now this is n dash is the total number of lines observed. See, from one station how many lines you are going to observe, that is going to be n dash, and n is the total number of lines actually what you are counting for that particular figure. S is the total number of stations, S dash is the total number of occupied stations. Means total number of station counting is totally different thing, and occupying that station is totally different thing. So these things you have to please keep in mind that while solving any kind of a problem, and this condition obviously it is going to come there. Now we'll see how to use that, or how to execute this. Now see, we are going to have one problem here. I'll show you. Just we'll take a trial, and then we'll go for the further calculation. Now if you take a problem, see the probable error of a direct measurement 1.2 seconds, compute the maximum value of R if the maximum probable error desired is, they given the maximum probable error, that is 1 in 25,000 and 1 in 10,000. So 1 in 25,000 and 1 in 10,000, that is the sixth place of logarithmic they have given, right? And means the ratio they have given, we have to find out the sixth place of logarithm to get the L value. Once if we get the L, then remaining things are quite easy. Now here if you see this probable error 1 in 25,000, that is 1 in 25,000, it is 4 into 10 raised to minus 5, it is going to be 0.0005, right? 4004. Log of 1 is 0.0, log of 1 plus 0.004, it is going to be 1.737 into 10 raised to minus 5. This is the sixth place. Now here sixth place is 17, right? Now if you count here, now if you see this, what is going to be there? Sixth place. Now here if you count, sixth place is 17, right? Now L is equal to 17. Now this is what you have to keep in mind. Here this is the sixth place. If you count 1, 2, 3, 4, 5, 6, sixth is 17. Now this L is 17, L square is 17 square, it is 289, and D, small d is given in the problem, that is the direction probable error in the direction, that is 1.25. Now you can use this formula, L square is equal to D square R divided by 3, that is L square is 289. 4 into D is given 1.24. R max we don't know, we are going to keep as it is, divided by 3, it is going to be R max is equal to 138.72, that we are going to round it up for 139. Now once if you get this R value, it is very easy or to determine the Rx in any case, right? For the second case, right? Second case also you can easily get the same way is there, because see they have given the for first case they have given the L they have given the ratio here, that is sloping ratio here. Now I'll show you, that is 1 in 25, right? 1 in 25,000, and the second one is here, it is 1 in 10,000, right? So for 1 in 10,000 in case 2 we are going to see here. Let me give some time here. This is 1 in 10,000, right? Probable error is 1 in 10,000. Now 1 in 10,000, just you are going to convert 1 divided by 10,000, it is going to 1 in 10 raised to minus 4, it is going to 0.001, and this log of 1, see this is 0.0. So if you add a log of 1 plus that value, this value, log 1 plus log of this value, you are going to get the log of 1 plus 0.001. Now it is going to be 4.342 into 10 raised to minus 5, it is going to be 0.0004342. Now here for the sixth place you will be having 43, L is equal to 43, L square is equal to 1849, then D is equal to 1.24, the 1.25 that is given in the problem. Then you will be having the L square value is here, it is 1849, 4 into D square, D is 1.25 into that is 1.25 square divided by 3 R max, we don't know, so we are going to get this R max, it is 888. Now this is the problem, what it is very easy and very simple. Only thing is that you should know the how to get the sixth place of logarithm. Then if you get that, it will be very easy to understand. Now this is what for this is very simple problem. Now here we are going to solve one more problem, that is the calculation of probable error in measurement of angle is 1 second and the probable error is 1 second, and the find the maximum value of R if the maximum probable error in the computing the side is to be limited 1 in 20,000. So this is very easy problem. I hope that you can easily calculate this, or you can easily go with this. Right, so we are going for one more problem, and this you can take it as this problem you can take it as a homework, you can easily solve this. And we are going for the no with the new problem with the triangulation figure. Now here you are going to find out the R value by using the values of D and C. So we are going to see that how the things will be there. Right, now see the in a triangle ABC, AB is the line, AB is the baseline, and the three angles A, B, and C are 70 degree, 45 degree, and 65 degree respectively. Find the strength of figure. Now strength of figure, see, it is very important to get the strength of figure. For that you require R value, and to get the R value you require D, C, and small a value. So first of all you are supposed to get the C. This what is C? C is n dash minus s dash plus 1 plus n minus 2s plus 3. This is the C value. So here n and S are the, see, this is n is number of side measures, and S is the, see, yes, for S is the total number of stations, and n dash is the number of lines observed in the both the direction. This is very important, in the both the direction n dash, and S dash is the number of occupied stations. So you should know this. Now we'll see that from this figure. Now here if you see this figure, A, B, C, all internal angles are given. How it is going to be, see, no, first of all we see that we are going to find out n dash. See here I have written n dash. N dash means no the sides which you are going to observe from, right, number of lines observed in the both the direction, right. All three sides can be observed from both the directions. See, from here C you can observe this side, and from that side also you can observe this line. From here you can observe this line, from this side also you can observe this line. From here C you can observe, right, observe this line, right. Here also you can observe this line, and from here also you can observe this side. So all three lines are like that, you can observe from both the sides. So that is n dash is equal to 3. S dash, see, all three stations are occupied, because all three stations angle they have given means all three stations are occupied. If suppose they have given only two stations angle, means two stations are going to be occupied if third station's angle is not given. If they are given angle means they are definitely they have occupied that station. Then n is the number of side of a triangle, three number of sides. Then S is the the total number of stations, three number of stations. So by using this, what you are going to have here, you are going to have C is equal to 1, and capital D is equal to what is that, capital D? Capital D is equal to 4, right. Capital D is total number of directions observed, forward and backward, excluding those along the line or fixed, right, along the line or fixed. That is sum of directions observed forward and or backward, excluding those along the uh, known or fixed line, right. So this is very important to understand or to calculate the D value here, right. Now here in this problem, see the D value, if you get the D value, right, to this single figure. Now here you will be having four numbers, right. Now how you are going to get that four numbers? Total number of directions observed, that you can get, right, and minus 2 also you can do there, that is also fine. But here we are having 4. I'll show you that how we have got that 4. This is, see, this is one observation side. From here you can do two observations, Here also you can do 2 observations. How many observations are there? 4. Now here you can do 2 observations. From B 2 sides you can see, and from A 2 sides you can see, right? And from C also you can see 2 sides. So 2 to 6, total 6 numbers of sides you can see. From that you have to deduct. See, no, D is total number of directions observed minus 2, that you keep in mind, right? That I have not mentioned here, but that you keep in mind. So that is going to be, see, 6 directions we can observe from all 3 sides. 6 minus 2, it is going to be 4, right? So A is 70 degree, B is 45 degree. Now small a, right, that small a, right, that is 7. Okay, small a is 7. Now you should understand what is this small a. Small a is 7. I have written this small a is 7. Now if you see this figure, what is this r? R is d minus c by d into a. This a is sum of rho a square plus rho a rho b plus rho b square. Now that is the table that what I have shown. From that table we have taken that value. Now if you see that what is the a, 70 degree, and b is 45 degree. Now you have to search that a and b from the table. Now a is 70 degree. Now here 70 degree is here. A is 70 degree and B is 45 degree. Now see here, this is 45 degree here, right? Here this is 45 degree. For that we are having how much value is there? That is 7, right? So that 7 I have taken here. So R is, see, 4 minus 1 divided by 4 into 7, it is going to be 5.25 is the R value, right? So that's 7 I have shown. So it is very easy, that one problem you can easily understand what is, how to get that R. Now one more problem I am going to solve with a number of figures, more number of this one will be there, a chained system will be there. Now how to get that, that we are going to see here. Now we'll see this third problem. See, I have written here the number of sides and all those things. It will be very easy to understand, right? See, they compute the value of C, D, no, C and R. This is C, D and R. This is D minus C by D means it is R, right? So you have to calculate value of C, value of, you know, if you want to calculate value of R, means you are going to calculate value of C and D. So directly, if might have they have given that value, you know, calculate value of R, then there is no need of mentioning C and D separately. So various nets they have shown. These are the nets or the figures or the systems. So here what we are having, see, first of all you should understand what is, you know, what are things to get. Now how to get the C formula? You can see this C is equal to, here will be n dash minus s dash plus 1 plus n minus 2s plus 3. This is the formula for C. And D, that number of, right, lines observed from each side minus 2, that what you have to, D means from probabilities of observing these sides, means number of stations what you will be having, from that how many sides you can observe, that we are going to calculate that D, right? So how to get that? You can see that, see, n dash, see, if you take figure A, right, about figure A, n dash, how many numbers are there? See, if you calculate, say 1 2, right, 3 4 5 6, then you'll be having 7 8 9 10 11 12 13, right? So 13 sides are there. So n is 13, n dash, see here the same number of sides are going to be there, right? Same number of total number of lines observed in the both direction. All the directions, see, from line 1, from you can observe from this side also, from this side also you can observe. So such kind of a lines you are supposed to take. So total number of this one are, see, if you might have a dash here, then there will be a problem. See, when solving this figure you will come to know what is the difference between n and n dash, but here we don't have that dash here, right? Now see here, we have got dash. Now so how we have separated this? See, why we have not separated? We have taken this line as 5 and we have taken this line as 6 full line. But here, see, because of this station we have made this as a separate, this as a separate, this as a separate, and this as a separate one. So this is very important thing, right? And s dash is the number of occupied station. So total number of sites are 7, total number of stations are 7, and occupied stations are 7 only. Now we'll just check it. 1 2 3 4 5 6 and 7 stations are there. Observation can be made from 7 station. So here you can see that how we are going to see. C we have got here, that is 9, and D is 24, because number of lines from each point can be observed are 26. 26 minus 2, it is 24 lines. So C is 9 and D is 24. We are going to have R value is 0.625, right? So this is what we have got from this figure 1, right? Now we'll see figure 2. Figure 2 is not there. You can take it as a homework. You can solve this as a figure 2 homework. I have not solved here. We are going for the one more figure, so that it can be very easy, or to complete the things it will be very easy, right? Else it will take a time. Now here you can see that compute the strength of A, B, C, D for each of the roots by which the length BD can be calculated from the known side AC. All stations were occupied and all angles were measured. See, n is equal to, here you can measure the sides, 1, 2, and this is third, this is fourth, fifth, and sixth. 6 sides are there, right? Totally 6 sides are there. Then what you will be having? You will be having n is equal to 6, n dash is equal to 6, s is equal to 4. 4 station, 1, 2, 3, and this is the fourth one, 4 point, and also s dash is equal to 4. Now see, we'll see that we can see the number of sides. This is the first number, this is second number, this is third number, this is fourth, this is fifth, this is sixth, right? 6 numbers are there. Now here we don't have, see, here we don't have the station, so we are going to consider this as second length only, right? So that's why it is, see that 6 numbers are there, right? So all these 6 sides you can see here, right? This is 1, this is 2, 2 will be from, 1 will be from here to here, 2 will be from here to here, and 3 will be from here to here, right? Fourth will be from here to here, fifth will be this side, right? And sixth will be from here to here. Why we have not taken this as 2 lines, right? Because we don't have any point here at the center, right? That is the thing. So we have taken this. See, by taking all these things you can easily calculate. C is here 4, D, see D, how to get this D is number of lines observed from both the points. That is 3 lines you can easily observe from 4 points. So that is 3 into 4 is 12, minus 2 is 10. So that 10 you can take here, and the R value is 0.6. The strength of figure by root 1, a triangle ACD and ADB, common side is AD, and then we can have the no for see this 58 degree and 55 degree, A is 6. As I said that you can see, you can go to the table and you can check it out, that value here. See this, here you can check this 55 and 6 is the value they are having, right? Here you can see this is the 6, right? For what value they are having, 65 and 50, right? 65 and 50, for that they are having, right? So we are going to see 58 means it is going to be 60, right? So the number of triangles, the see, you can easily find out the strength. As I said that from one more route, if you take this ABD, if you take this route, you are going to have A is 12 for 129 and 28 degree. Now this value is 18 from the table, you can easily find out R1. Then for figure 2, the strength of figure by no second direction, that is ACD and DCB, you can solve this problem by both the directions. So which direction you are supposed to see, both the direction means, see, will be having, you can take this whole figure as a one direction, and this I can take it as a whole figure as a second direction. So by 2 directions you can solve this problem. You can solve this for R. Probabilities are 2 different methods are there to get this R. So that you can easily follow, and you can get the R1 and R2. Even one more, that is third route is there, that is of ABC and ABC and ABD. The fourth route is there, ABC and BCD. You can get these things done by all 4 routes, right? And you can get the R values. So different R values, see here I have got with reference to the different angles or different routes. As I said, you can solve it by any 1 or 2 routes, that is enough for the answer. But if you go for the multiple routes available to solve this figure, it will be very useful. Now this is what from my side. Thank you very much.